Okay, so this video is meant to introduce you to the idea of forces in two dimensions, and we're not going to really learn any new equations for this unit. We're just going to take all of the equations that we learned from the past unit and just apply them in cases where you may have forces that are not just in the x or just in the y. So the key thing to understand with forces in two dimensions is that any force that is going at an angle would need to be broken up into an x and a y component. And we do that using SOHCAHTOA. Just like we would break up a displacement vector into x and y, now we're going to do it with forces. And we are still going to stick with the fact that we are going to combine horizontal forces with horizontal forces and vertical forces with vertical forces. So only horizontal forces combine together. And we do that, we saw that before. My horizontal forces combine, dot, 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 it's going to equal MA, and only vertical forces combine. So again, my sum of my vertical forces, whatever those are going to be, are going to equal MA. MAX and MAY. So I just want to go through one example of a case where you may have, a case where you do have one force that is going at an angle. So in this situation, it says two forces are shown. I gotta think of shown. Shown acting on an object, find the net horizontal and net vertical force. So if I have an object and I have one force, I'm gonna call that force 1, and it is 10.2 newtons. It's being pulled upwards. And then I have a second force that is at this angle of 120 degrees. I'm just making this up. And I'm going to call that F2, and it's going to have a value of 16 newtons. So I have this object being pulled in two different directions. And I want to combine them. I want to know, well, what's the net horizontal force and what's the net vertical force? If I think about just like an axis, a coordinate system, like this, you can see my F1 is along that y-axis, so I don't need to break that one up. But my F2, this 16 newtons, it is going in a direction like southeast, and so there is definitely a component of it that is going in this direction, and I would call that F2x, and there's a component going in that direction, I'd call that F2y. And from the initial problem, you were told that this angle, this entire angle, is 120, and we know that for any axes that this is 90 degrees, so that means that this just inner triangle here, this angle is 30 degrees. So you can see how we could use sines and cosines to figure out what F2x and F2y are. So if I were to look at F2x, F2x is adjacent to this angle, and so for the adjacent we're going to use cosine. So cosine of 30 would be equal to F2x over the hypotenuse value, which is 16. And similarly for F2y, F2y is opposite this angle, so we would use sine. So sine of 30 would be equal to F2y over 16. And to go ahead and take a moment to calculate these out, remember you have to be in degree mode in physics. So calculate those out and get two values, one for F2x and one for F2y. And when you calculate that out, you should get that your F2x is 13.86 newtons and your F2y comes out to be 8 newtons. Okay. So that's just, there's a portion of F2 going this way and a portion of F2 going that way. Now if I were to find what the net force is, I would actually look at, well, what are the sum of my forces? So horizontally, the only force I have going horizontal is this F2x. So horizontally, my F2x is just going to be 13.86 newtons. Vertically, I have 10.2 going up, and I have this F2y going down. I have this 8 newtons going down. And so I have one going up, one going down. The way I'm going to combine them is I'm going to subtract them. So I would say 10.2 minus 8, and that would give me a value of 2.2 newtons. So horizontally, I've got 13.86, and vertically, I've got 2.2, and that's where this problem ends. The problem, I guess, could go on and say, well, what's the net resultant force? And that reminds you, resultant displacement, you can have a resultant force. And like if it were to ask you what the resultant force is, you would draw a new triangle and say, okay, horizontally, I've got 13.86 newtons. Vertically, I've got 2.2 newtons. And then my resultant force, I'll call it resultant, would be the Pythag of these two numbers, and then you could figure out the angle for the direction. So when you get back into class, we will do some more examples of finding net force horizontal, net force vertical, and even doing some resultant forces.